Good morning, good afternoon, good evening, and welcome to the fifth day of our conference on the International System of Units, the SI, in fair digital data. Today we're going to have two sessions. I'm Martin Milton, I'm the director of the BIPM. I'm going to be chairing the first of those sessions alongside Daniel Hutchenreuter from the PTB. Now, I hope you've been part of the conference over the last 4 days and been able to benefit from speakers we've had. To give an idea of what's been going on at the conference, we've had now 62 speakers, and we've had the meeting coordinated by 40 chairs and moderators. And it's been a meeting that's been very active with a lot of questions and answers. In our first session back on Monday, we had 600 participants. In the sessions on Tuesday and Wednesday, we had an average of 160 participants in each of the sessions. And in the breakout sessions yesterday, there were 95 participants in each of those parallel breakout sessions in both of the time zones. So there's been a lot of discussion and there's a lot to summarize. So what we've done today is to invite 4 people to summarize the contributions made in the regional sessions, and then we have 4 to summarize what happened in the parallel breakout sessions. So I'd like to move to introduce our first speakers. So these will be these will be providing some summary for us of the material that was presented and the discussions that went on in the 4 regional sessions. Firstly, I'm going to introduce Dr. Sascha Eichstädt from PTB, who will summarize what went on in the sessions in the European time zone. Dr. Weinand Lau is going to summarize from the AfriMet's perspective what happened also in that session. Dr. Thomas Liu from A-Star in Singapore will summarize what happened in the Asia Pacific session. And then finally, Dr. Hugo Gasca from Sanam in Mexico will summarize what happened in that SIM time zone session. So now I'd like to hand over to Sascha Eichstädt to give us a summary of the discussions and the material presented in that session that you were very much involved with. Over to you, please, Dr. Eichstädt.
Thank you very much. Thank you very much for the introduction. The session on the regional metrology organizations, the RMOs, was very interesting. There were a whole lot of interesting points raised and many discussions, and it's very difficult to summarize that in a very few words. So I tried to pick out some of the elements that to me seemed remarkable and very important. And first, from the presentations given, there were some points that stick out to me. And firstly, I was very impressed by the APMP and SIM questionnaires that they did. Particularly for APMP, there were very, very interesting details given in the presentation from feedback from the members and stakeholders and such. Also, I like that not only Euromed, but also SIM established a dedicated work group to foster a harmonized development in digital transformation. In particular, the harmonization was an issue mentioned in the discussions afterwards several times. Primary focus in the RMOs seems to be on digital SI, which is, of course, good because that's also the focus of the conference, and digital certificates. Although it was mentioned that a clear definition and specifications are still missing, so that may be an issue for proceeding further or need to be resolved firstly. Euromed already has a digital strategy as a sub-element of its overall strategy, and I like to see that also SIM established a subgroup to work on the digital strategy. Overall, I saw that there are many common challenges and requirements between the RMOs, and it was very good to see that there are also many collaborations already started and on the horizon. In the question and answer section in that session, there were also many very good questions and good discussions, and I try to pick out some that stick out to me. One important was that we need high speed in the further developments because the world around us is changing quickly. And one thing to do that was suggested by starting the developments at the NMIs and not wait for an RMO decision. And from the NMIs, bring it to work groups and to RMOs and beyond. The role of work groups and RMOs is such to foster the developments, to harmonize it, and also to foster the developments in smaller and emerging NMIs. So they have a very important role to not leave anybody behind. The role of the BIPM then is to foster the same on an international level and foster there also the harmonization and collaboration, like this week bringing communities together, which was very well received and much appreciated by the attendees in the Q&A. There are many new skills required from methodologists, for instance, on software, on data, artificial intelligence, and that also led to the conclusion that there's a paradigm shift in training and capacity building. So it's not only or no longer only the small and emerging NMIs that may need capacity building, but also some of the traditional ones. And I wouldn't exclude PTB here, by the way. And it's necessary to bring in external expertise to put NMIs on speed. It was said several times that the pandemic accelerated some developments. Example given were remote audits and opened new opportunities, for instance, by new programs for funding by the governments. And my conclusion from that is that there are many opportunities on the horizon, and we have a good start made with the conference this week, and we should continue from there. Thanks.
Thank you very much, Dr. Eistat, for that summary. I think our next presentation is from Dr. Lowe, and this is a pre-recorded presentation, I think.
We had a very good workshop this week, and especially the session that the RMOs, the three RMOs, Euramed, COMET and AfriMed had on Tuesday, was very interactive. And I'm now going to give you a short summary of what AfriMed is taking away from this week. After the session on Tuesday, I was contacted by my CIPM colleague, Dr. Thomas Liu from Singapore, and he alerted me to this document, the Digital Transformation Strategy for Africa, a policy of the African Union Commission. And this just shows the power of working together and liaison. I had sight of this policy a while ago, but basically I can use it now to summarize what we have learned for AfriMed and what we will take away to our General Assembly to discuss for a digitalization strategy for AfriMed. So the DTSA for Africa is based on several foundation pillars. For metrology, the most important are infrastructure for a digital financial services, industry, trade, health, agriculture, and education, and then to support a digital ecosystem. So what did we hear this week? AfriMed primarily focuses on basic metrology services, and especially those for legal metrology. Only sub-regional hub NMIs participate in consultative committee activities, and only 2 participate in global metrology digitalization efforts. NIS of Egypt and NMISA of South Africa have committees for digitalization activities. They are small, but they exist. Digital certificates and infrastructure to adopt digital technologies are arguably the most important considerations for AfriMed. What could be the AfriMed digitalization strategy? And we actually will discuss it at our upcoming General Assembly in 2021. We could, for example, partner with the other RMOs, with Euramed to stay informed of new technologies and developments or to participate in their MP projects. APMP to participate in the development of solutions fit for purpose for developing economies. From Sim and COMET, I picked up that they are working on infrastructure solutions, including digital networking and solutions for developing economies. And of course, we can participate in that and collaborate with them. But it is also very important for AfriMeds to influence the metrology digitalization strategy at international level to cater for developing needs. As I see it, the CIPM will lead the process to partner with other IOs for a fit-for-purpose development of metrology for a digital world and the standardization of concepts and issues of interoperability. The leading NMIs in the field will partner through the consultative committee structures to develop and implement the digital metrological concepts for quantities, units, symbols, and address issues like uncertainty of measurement and so on. The BIPM programs then need to include the aspects of digitalization crucial for developing economies. So there are the issues of digitization of the SI and key comparison database material, but it must be done in a way that it is accessible by the developing world. And then, of course, the very important issues of awareness and technology training. But the most important thing that we will take away from this workshop is that AfriMeds yesterday already discussed to form an AfriMeds Digitalization Interest Group. We don't necessarily have the critical mass for an active working group, but this group with a core membership of those institutes with links to the international effort can keep AfriMeds members informed of developments, identify elements to be developed in line with the AFCFTA policies, plan AfriMeds projects like awareness, training, infrastructure needs. We can approach the African Union Commission and developing partners for continental DSI-related projects. And the first project to develop an AfriMeds capabilities repository to support intra-trade is already being motivated to the AUC and a developing partner. And in this case, it's actually PTB. So there's already a very good link to what is happening in Europe. Thank you very much. This is what we think AfriMeds can take away from this workshop. Goodbye.
And we'll hear some words from Dr. Thomas Liu, who I think is also has a pre-recorded presentation.
Good day, everyone. Let me first say a big thank you to the tremendous effort of the organizer of this online workshop to bring it to the global community across different time zones. Thank you to APMP colleagues who hail as far east to the Pacific and as far west to the Europe for your participation. We have a pretty good turnout for the workshop, as you can see on the chart here. For day 2, we have close to 180 participants. And for day 3, we have about 115 participants on average. Thank you to the speaker for the excellent presentation and the panelists for the very useful and engaging discussion. Over the 2 days, we have learned much about the vision, initiative, and progress of the digital transformation among QI partners, RMOs, global data science community, the industry, as well as the technical community. I will not summarize the talk, but instead I will summarize the key takeaway from the discussion across the topic categorized in 3 areas. The first one on stakeholders' interaction and collaboration for digital transformation. Second, on the skills and competency that might be needed for digital transformation. And the third is on awareness and outreach. And I will end with a discussion of some of the preliminary needs and action APMP will take. On stakeholder interaction and collaboration, we discuss about how we can execute digital transformation project and with who. Our international QI partners, OIML, ILAC, ISO, IEC, they or involve important key stakeholders like the regional members, regulator, end users, industry, and technical committee in the digitalization initiative and projects to make sure that the requirements are well defined, work is fit for purpose, while also taking into account the varied needs of the member. ISO TC 215 on health informatics and ISO TC 12 on quantities and units in health describe their close collaboration, enabling some of the projects in e-health record, and also their collaboration with UCOM, a technical committee, one on the ambiguous digital representation of units used quite broadly in science, engineering, and business. ILEC show us how they use cases, how they share use cases on the web for learning for their members. And for the RMO, we thought that we can learn from previous successes like the CIPM MRA effort or this SI redefinition, where we saw strong collaboration among the RMO and also the NMI, and where partnership with key organizations like the International QI Organization, as well as scientific unions like IUPAP and IUPAC, among others, were so important. There was also discussion on what skills and competency that might be needed to be successful in digital transformation. So the discussion brought up the need to bridge the IT gap and to upgrade the IT knowledge through either a competency paradigm shift or a complementary skills complementing the current metrological skills in the NMI. SIM shared the approach of determining digital transformation readiness of their members, as well as participation in agile project where they learn through hands-on collaboration and doing, and also they're learning on change management. Many of the RMOs are initiating digital transformation activities, and there's much to learn from one another, particularly through shared experiences, knowledge, and learning in digitalization. There's also a need for cooperation for the harmonization of the digital calibration certificate, and particularly in building capacity across the region where we have a diverse spread of metrological capability. It was also discussed that digital transformation is not new, but it has hastened by the rapid technological change, particularly in improvement in connectivity, computing power, and algorithms, and its ubiquity. Digital transformation is said to be a means to an end, and it's not an end. So open mindset is important. So is the ability to trash, the ability to connect dots in complex problem solving is important. Digital transformation, we can learn from the past experience, for example, in communication, where we have gone from snail mail to email. There has also been an example of digitalization of certificates, like the e-certificate that was done to avoid counterfeiting and fake certificates. These are perhaps past experiences where we can learn from in our journey on this new digitalization effort. More specific to the technical needs for the digital representation of unit, we learned there exists some widely used ontologies and vocabularies like UCOM, QDT in some community of practices. However, there's still a need to map and study them to identify any gaps to enable interoperability and to see how the metrological definition and digital SI can fit in. The community find that a machine-readable SI brochure like the VIM and GUM would be very useful. Many of these digital representation of units, ontology, vocabularies like QDT are run by volunteers and retirees, and thus they may need a more permanent home with a governance body for the continuous maintenance of such infrastructure. The participant said that the workshop brought great awareness of these digital resources on the representation of measurement data and digital projects such as UCOM, QUDT, SNOMED, and the ISO TC215 project and so on. At the same time, the community of practice also found that the workshop was very useful for the sharing and facilitation of exchanges in digitalization efforts, like those done by NCLSI, MII project, and also by the expert group and CoData Drum. Such a workshop has been very fruitful for facilitating better exchanges. And last but not least, we heard from Dr. Takashi Usada presentation on the APMP region's initiative in digital transformation. However, the progress is very varied and is as reflected by the broad spectrum of metrology capability as well as the diverse needs of the region. A symposium on metrology for digital economy was convened in APMP General Assembly in Sydney in 2019 to create awareness. The APMP is planning to establish a focus group to plan and prioritize digital transformation activity. They are also planning to establish common interests and needs and to coordinate the effort among the different NMIs in the region. The APMP DEC or Developing Economy Committee Future Proving Task Force is supporting the member with emerging metrology system. They are working with the SIM partner, in this case PDB, to develop the digital transformation process. Cooperation with RMO and coordination by the CIPM and BIPM would be beneficial, particularly in the area of exchanging and sharing experiences, and also in efforts in harmonizing practices as well as in capacity building. So with that, I thank you for your attention, and this is the brief report from the APMP region presentation session. Thank you.
Thank you for this excellent overview of the summary for the Asian and Pacific region. We now come to the talk of Dr. Hugo Gasca, who will give us the summary from the sessions in the American region for SIM. Welcome, Mr. Gasca.
Thank you. Yes, thank you. Good morning, good afternoon. I'm looking for my slides. As all the previous presenters, I thank this invitation. We have a similar findings, I would say, during this sessions. So I will not repeat all the details that already have been done. And basically, I will start just with sharing with you the formalization of the working group at SIM focused on digital transformation. So last year we start working on this in an informal way, and now this progress that I want to share. We have representation of 20 members out of the 31 members from SIM as economies. And I will not mention all of these participants. I congratulate with them. Just to let you know, this is a formal effort now at the regional level. One of the things that we also want to mention is a focus on this Inter-American Development Bank project that will bring resources and opportunities to the whole region, and also opportunities to collaborate with some other meteorological regions around the globe. So this was funded by, as I said, by the Inter-American Development Bank, and actually currently we have at this point 10 participant countries, but and you can see them here in the middle, but they are not. This is not closed effort. More can join, obviously, within the SIM region. We have a general plan approved for this project, and just this week this was confirmed and signed, so that we are having progress. And our next step is to detail the next level of this plan, of this project plan. What we have as conclusions, what we can share with you is that the need for training for the metrology community, again, it's kind of repeating some of the points that were already written down. That is about capacity building and knowledge bridging different areas that require not for the metrology community. There is also, we detect an increasing need for human resources. We detect a lack of human resources in informatics, specifically, that they are difficult to hire, at least here in the region of the Americas. We mean the people with credentials on emerging technologies and sharing experiences on this. We also detected an increased need we also see it as an opportunity to collaborate among regions. That is efforts to strengthen the NMIs from different places, and also the need for harmonization of methodologies as were shared before. Like we have different efforts for ontologies, for systems of units already. We have the new one from PTB and pushed by BIPM. But we realize there are more options, and we would like to unify, to harmonize, to agree on which is convenient for the metrology community. And we also see an urgent need of coordination of these efforts to achieve this digital framework for the SI, and also the propagation of this by using or holding the fair concepts for digital data. I thank you. I think this is all we can recover from the previous sessions. Thank you very much.
Thank you there for those summaries. We're now going to hear some summaries from the breakout sessions that took place in parallel yesterday. And at the end of those, we're going to open the session up for questions. So please start putting any questions you might have into the question panel press. So firstly, I'd like to introduce the four speakers because I think they're going to speak off the same set of slides. We have Blair Hall from MSL in New Zealand, Alistair Forbes from NPL in the UK. We have Robert Hanisch from NIST in the USA, and we have Daniel Hutchenreiter from PTB in Germany. And I think, Blair, you can start the presentation.
Thank you, Martin. Danielle, are you going to control the slides? So the...
Sorry, I don't. Now I have to control. Please 1 second.
Our breakout sessions were occurred in 2 time zones, and in each time zone they were repeated twice. So there were in fact 4 discussion sessions that I'll try and summarize when I have some slides to talk to. So here we are. So as I was explaining, we had discussions going on in 2 time zones, and so our chair in the first time zone was Jadia Burjadan from the National Metrology Institute in Thailand, and in the second time zone we had Jesse Pillay from the National Metrology Institute in South Africa. On the panel we had Robert Brown from Mitutoyo and myself. We attended in both time zones. And in the first time zone, we also had Simon Cox and Marcus Foster from CSIRO Australia and Rod White from MSL New Zealand. In the second time zone, we had Francisco Flamenco from CNAM, Mark Custer from the NCSLI United States, and from NPO we had JT Johnson and Richard Brown. So I've just got a couple of slides now, 3 I think, which I would like to, oops. So a brief summary of some of the points that came out of our discussions. First of all, the use of the term interoperable actually has slightly different meanings within the context of FAIR and in metrology. So in metrology, we have a concept of traceability, which in some senses is interoperability, but it goes beyond that. And so we must be aware of that. And it was suggested somewhere else that we might like to describe what we have in metrology as FAIR plus traceability. Some good news is that our experts in representation systems felt that the representation of quantities of units is basically a solved problem. We heard a fair bit about some of the ontologies and services available, and those seem to be very well developed. However, within the SI, the kind of quantity, the semantics associated with kind of quantity, it was felt that that was a bit neglected and too much attention focused on dimensions, which are not really used properly. Another point was that we felt that there can be misunderstandings about when we say that measurement should be based on the SI. What is important is the traceability to realizations of SI units. And we mustn't confuse that with representation of measurements in other unit systems. So where there are customary unit systems, but the underlying measurements are traceable to SI units and scales, that's not a problem. So there's a terminology issue there. People may be worried about pints of beer disappearing and things like that. And one of the issues that we felt quite strongly about is that the way to put metrological notions into the SI core, such as uncertainty, it seems to us unclear still. There seems to us like there's quite a lot of work required to capture metrological notions. Now, trying to advance the slide. There we go. One of the issues we felt was the scope of the project. There are really very many measurements done in the world. The SI encompasses a tiny fraction of them. So I think we felt that we needed to decide just how much we were biting off here. It'll be essential for the metrology community to engage with really quite a wide range of experts to cover all of the different kinds of measurements. And indeed, one thing that seems to be lacking is that measurands need to be identified. There are many kinds of measurements reported in SI units, but they can't be understood from the results alone. You must understand what is subject to measure, what is intended to be measured. And examples of this, for example, material properties or RMS voltage, where you need to know the waveform or particle sizes, things like that. And finally, fit for purpose solutions are really the key. It was felt that NMIs can complement efforts that are going on elsewhere, like the representation of units, by finding out really what stakeholders could use. And perhaps this will be before they're even ready to formulate the question and ask for it. Trying to understand the needs of our stakeholders is paramount. And NMIs can take the lead in developing representations of metrological concepts, such as traceability, uncertainty, dealing with dimensionless quantities, which seems to be a difficult issue, and different types of scale as well. We don't just have metric scales, but there are other scales like ordinal and nominal properties, which need to be handled with different considerations. And finally, and importantly, we must ensure that everyone becomes involved in the digital transformation and implementations of interoperability. These have to be equitable and global. And so there's a role perhaps to think about ways of supporting different areas of the global quality infrastructure through secondments, training, and such like. So that's a very brief summary of our thoughts, and I'll hand back to the next speaker now.
So thank you very much, Blair. I will give a summary of breakout topic number 2, which was machine-actionable metadata and data and the FAIR principles. We again had these 4 sessions in the 2 different time zones. I began with a summary of the FAIR principles, what we mean by machine-actionable, and how units of measure need to be folded into the FAIR principles for interoperability and reusability, because they are not explicitly addressed in FAIR per se, but they're essential for proper interoperability of data. We had a very interesting presentation from Ian Smith of the National Physical Laboratory and the SmartCom project, talking about machine-actionable metadata and data on the basis of the SI, VIM, and GUM. And he, in fact, showed a very nice example of the encoding of units of measure and uncertainties within an XML schema. So this was a very nice setup for the discussion that followed, in that we discussed the various aspects of how to encode metadata for interoperability. Next slide, please. So the main discussion topics focused on the use and reuse of existing metadata schemas, data dictionaries, and ontologies. There was, I think, a broad consensus that we did not have to start from scratch, but that there's a lot of experience that we can build upon and reuse common metadata elements where possible. This is an example that was very clearly shown from the GoFair community, where high-level metadata elements such as the experimenters' names and the organizations where experiments are done and so forth clearly span multiple disciplines. But we also have to recognize that each discipline will have special requirements, terms that are unique to that discipline. And we have to work out ways to rectify metadata schemas where, for example, the same name is used for terms that actually mean something different, or where the same concept has been implemented using different terms. So there's a rationalization effort that needs to take place there. In order to make progress, we need collaboration between metadata experts and domain experts. Metadata experts, by this I mean people who are experienced with developing metadata schemas, who have an appreciation for what is the appropriate level of granularity, what's too little metadata, what's too much metadata. And then, of course, the domain experts who guide this development effort by knowing which are the most critical metadata terms and concepts to encode in standard schemas. We also discussed the fact that proper expression of units of measure and uncertainties is essential for interoperability and reusability. But we recognize that of the four FAIR principles, the interoperability and reusability ones are indeed the most difficult to achieve. And lastly, we had some discussions about data quality. How do you ascertain the quality of a data set or a data collection? This can be very difficult. It might be expressed through uncertainties. Not everybody does uncertainties properly. And so there are also issues of reputation that go along with assessing data quality. The FAIR principles do not explicitly address this. So this is an issue that I think is particularly germane to us in the metrology community to find some ways to express data quality, fitness for purpose, such that users of our data can be confident in which circumstances the data is appropriate. And that concludes my summary.
So thank you. The next summary is for the breakout topic number 3 on the digital calibration certificate. So first of all, thanks to all the contributors to the session, the chairs, the moderators, and of course also to the panel speakers. They really added much to our discussion. A special thank also to our presenter, Andrei Pankov, who spoke about the requirements and the structure of data formats for digital calibration certificates. And he really gave an excellent overview on technical aspects and operational aspects you would deal with for DCCs. In general overview, what is relevant for the topic and what are the benefits. So a digital calibration certificate can improve the availability of calibration data and make the exchange easier. You could benefit from its uniformity regarding unified formats that allow a more clear interpretation of the data. Of course, you need to protect the data in a digital calibration certificate, so you need to consider cryptographic safeguard for the reliability of this data. For the authentication of the calibration data, digital signatures give a additional legal value. Then in case of the storage, the digital machine-actionable format allows easy storage, and the data could be used by software too. And finally, also the digital formats allow automation of assessment. So one thing that was asked many times and discussed is the question, what skills are needed, and it was seen that there is a need for skill development, capacity building for creating and exchanging DCCs and the communities using calibration. We also had a view, what would it need to have a full digital laboratory? And here the answer is that this will be certainly work for many years. Yeah, then also one important topic for the participants was that the data in the digital calibration certificate really needs to be protected from manipulation. And also at the moment, depending on the country where you are, the introduction of electronic signatures and the use of them may be accompanied by several issues. So there's much to work on in the next years. Also, it was discussed to also envision cloud solution for future storage and also the exchange of digital calibration certificates. Then we had a quick review and discussion with the speakers on various important developments that we see at the moment. So also shown on day 3 by the presentation from NCSLI, the measurement information infrastructure is one important development. And on the other hand, we also had an insight to the XML DCC structure that is at the moment developed by PTB and in the European project SmartCom. The important link, machine usable link between calibration certificates and machine readable calibration measurement capabilities seem to be a requirement for the future, and it's required to have interoperable terms that could be used for all these areas, like in calibration. You need uniform, similar solutions for presenting quantities, uncertainties, equations. And it would also benefit, for example, from similar presentation provision of statistical distributions and so on. One first outcome was really from these discussions that it motivated the participant really to look at follow-on events, follow-on discussions. So certainly what will happen is that the people in the panel will come together again and continue their discussion how they can come together with the developments and calibration and capability and accreditation databases. One question that was also asked quite frequently is what it will need to get towards really international agreed DCCs. And the answer here is that stakeholder communities on different levels have to be involved. This is also requiring from the stakeholder communities not only to listen and to learn what's a DCC, but they must become active on their own to agree the content of the DCCs for their domain. They are the experts in their calibration domain and have to decide and agree upon how to represent their data in a DCC. And some additional information, so very important temperature, humidity, and pressure calibration certificates, as they are used today in almost all laboratories for fundamental measurements. Yeah, finally, there was the question towards CIPM, if there's already a view on the DCC development. So here at the moment, the CIPM expert group has not gotten deeper into that topic and cannot make a statement. For those who are interested to get some more insight what the CIPM expert group is doing on the DCC or like to get involved a little, you can establish the contact through the CIPM task group on the Digital SI. You find the contact at the BIPM webpage of that task group. And finally, we saw that really to progress the DCC topic, further investigation is needed and discussion to understand how existing approaches for calibration data, for measurement data can compare. With that, I'm at the end of the summary. Thank you.
Thank you, Daniel. Can you move the slides on to the breakout topic 4, which was on readiness of data for AI and machine learning? Again, we did 2 time zone sessions, first chaired by Valerie Coleman, the second by Marina Romanchikova. I gave a talk about the introduction to the topic, and Marcus Bayer from PTB gave a presentation on reference data for trustworthy machine learning in metrology. Next slide, please, Daniel. So the sort of topics that came up was, first, there was a need for active collaboration and exchanges between the metrology community and those working in data science and knowledge engineering and the AI and ML community. So there's no point in the metrology looking for solutions from within the metrology community itself. We needed that exchange. And certainly, what can metrology and the quality infrastructure learn from other science disciplines, life sciences, astronomy, and so on, that have also been tackling issues to do with data and machine learning. There's a need for high quality reference data, but perhaps a need also for reference models, digital twins, with a transparent quality and provenance indicator. So how do we measure the quality in data? How do we measure the quality of models for analysis and AI and ML? And in particular, we talk about data a lot in this conference, but should we also be talking about models and their role in, for instance, digital twins and an analysis? An interesting topic brought up by Marcus in his presentation was the generation of synthetic data using digital twins for training machine learning algorithms. And the discussion also involved quite a bit about, do we need some sort of quality infrastructure for computation analysis? Again, we've got one for data, for measurement, but how do we know if a particular computation and model and so on is fit for purpose? We talk about uncertainty quantification now, which is a broader view of uncertainty. So we taking into account that we may have specification uncertainty because what we're talking about hasn't been written down in a formally enough language. Talk about data uncertainty, but also model uncertainty. And the fact is that computation is in practically every calibration chain. And if that computation element isn't qualified, then we risk losing that traceability. So what would a quality infrastructure for AI, for instance, look like? What would it do and who would be doing it? Next slide, please, Daniel. Another interesting aspect was the FAIR principles. We tend to focus a little bit on the FAIR principles allowing machine learning to have access to data. But in fact, what happens with the outputs of the analysis? Who gets to see that? Well, that has to be made fair also. And that means that the provenance of the outputs, which includes the provenance of the models and algorithms and the training data, that has to be somehow captured. So I think that's an interesting area. There was some discussion about whether or not current ontologies, and do they represent the SI correctly from a metrological point of view? And we've already had some issues about the representation of dimensionless quantities and where an area where the NMI community, the metrology community, they can add some clarity. And again, going back to the issue of digital twins and analysis and machine learning applied to metrology, there was some discussion about the fact instrumentations in a digital framework would be a lot more self-aware. They would understand what was going on in their environment, be able to create real-time uncertainty budgets, saying this is the uncertainty you're getting from my instrument at this point in time, at this point in the laboratory. And broadening that out, can we regard a whole complete laboratory like a complete factory as a large entity for which we can create a digital twin and assimilate data streams in the laboratory and to improve how the digital twin reflects the actual behavior of the laboratory. So there are many interesting points of discussion there. So that's my conclusion, my summary for that discussion.
Thank you very much.
Thank you very much.
Thank you very much for those summaries. And we've now got some questions coming in, and we'll take them actually according to the interest in them shown from those of you participating. The first question, which is for all of the panelists, is we have heard about a lot of use cases in the different sessions of the workshop. Can I ask each of you which use cases you think are now the highest priority to be addressed by NMIs and by industry? Can we start with Sasha Eichstadt on that?
Yes, I'm happy to take that question. So when you consider the digital SI, the first use case that I would think is the most important one for NMIs right now is digital calibration certificates. It's something that we were asked, or we are asked by many of our customers and stakeholders, and it was mentioned in several of the talks in the RMO session in particular. And it's an excellent test case to what is required for digital representation of units and quantities and uncertainties. So DCC, I think, is the most important one.
Okay, thank you for that. Vinand, do you want to come in on this one?
Yeah, Martin, I think the things that we already identified for us that our stakeholders really need is that the core SI are basically usable in digital format. So I think that's probably what I would think one of our first tasks is. I think that Alistair just said that the current I asked the question if the current ontologies are representing the SI correctly. And the things like the dimensionless quantities and so on. So I really think those are the things that the CIPM are really looking at first to make sure that that is really usable, that it is there, that is correct, that we can address all the issues from our user communities.
Thank you. Thomas or Blair, can you bring us a perspective from the Asia Pacific side, please?
Yeah, sure. I'll take that. As you saw in my presentation, and also maybe also in Usuda's presentation, we did a survey of the region and had a sense of what the region thought might be some of the priority. I think they said the main one is like what Wyman has said, to have the digital SI core ready. And I think with that, then we can perhaps then do things with digital, certificate. So I think those are the key priorities in the region here.
Thank you. From Hugo Gasker or Robert Hanisch, could you respond from the perspective from the SIM side?
Thank you, Martin. I agree with all my colleagues. We think on the DCC as the main step to do, but we think of the whole life cycle. Is not just getting the DCC by itself. Is just we need to think also on the middleware to get used by the clients, by the customers, and so we need to bring all this connection and give all this benefit to the end user. So of course is the system of units, the digital system of units is required, the ontology or the upgraded BIM to consider these digitalization issues, the traceability, metrological traceability, but thinking about the whole chain of value for the community. Thank you.
Thank you for that.
I would just add,
please, yeah.
Martin, that I've been collecting these use cases. Several of them address important interoperability challenges, like in biomedical and dosage measures and so forth. So there's some real world immediate problems that need to be solved. The other reason we're looking at these use cases is because we can't solve the entire world of units of measure interoperability all at once. So we'd like to find those tall poles that if we address those, we can actually solve a large interoperability challenges.
Okay. Can I ask bring in another question and ask the three panelists who haven't spoken yet to address it? And the question is, what is the best way and most useful forums for the metrology community to interact with those communities developing and curating ontologies, such as the UCUM and the QUDT? Blair Hall, could you start us off on that, please?
I'm not sure I can take you very far on that. I've learned a lot about UCUM and QUDT during the workshop, and I don't think that I know the best way that we can engage with them, but I'm aware that they're very open to exchange with us. That's their systems which are evolving. I'm sure that something can be found. If I were posed this question, I'd pass it straight on to Bob, to be honest.
Shall we do that? Shall we go straight over to Bob?
Thank you. Thank you. Sure. I want to remind people that we have established now a close collaboration between BIPM and the Digital SI expert group and the CODATA task group on digital representation of units of measure. So I think the conversations are now happening, and we need to make sure that those conversations are brought to light amongst the community of stakeholders that are represented at this conference. We'll be doing that also through CODATA. We are reaching out to the international science unions. We have a board of ambassadors of about 30 representatives of the international science unions who will also act as a sounding board and help us to identify the most challenging problems in units interoperability.
Thanks for that. Any other comments on this question?
If I can just add, Martin,
please.
To Bob's comment. Yeah, so there are these communities out there that are already doing lots of work in this area, and I think easiest for the metrology community is to use, for instance, CODATA, who are a like-minded sort of group of individuals who are already engaged in this activity, that we can somehow use them as a partner for us to get more involved in these areas and in the Research Data Alliance, for instance.
Okay. Anything else on this one? So, please, Sasha, Alex.
Thomas was first, I think. Thomas Liu.
Thomas, please.
Okay, thank you. I thought that, you know, this is an evolving field, and also that the different RMO and NMIs are developing capability. And I heard from the RMO presentation that each one of us are also starting to have a task group or focus group within the RMO to interact and look at the issues of, you know, digitalizations and so on. I think at some point this structure would be one that can be used to interact with the outside community, like what was mentioned early on with the CODATA, with the QUDT and so on, those communities that are already working on the digital representation of units. And I think this kind of interaction would be very beneficial for bringing metrology, you know, domain knowledge to the representation world.
Thank you. And Sasha Eichstedt.
Yes, thanks. I just want to add that I think it will be important to find a common understanding and common language with these external groups. And again, here, a very good use case could help to start with something very concrete in this collaboration. So not just approach them saying we want to collaborate with you, but make it concrete.
Vinand, would you like to contribute to this? It'll probably be something that comes up in the next session, I guess.
Yes, I think so, Martin. So particularly on the issue of how we actually cooperate with groups and international organizations already working on this. Is this the question that you want me to respond to? Yes, of course. I think this week was very valuable in that sense, that we had so many role players that contributed, and I, for one, learned a lot about the other groups like USU, UM, and so on. And of course, our expert group needs to now come and advise us on exactly how do we proceed. But from my side, my main aim probably now will be to really interrogate and go through everything of this week again and really try and identify how can we not reinvent the wheel, but really work with all the stakeholders and all the parties that already has done a lot or have done a lot and are still doing a lot. I think this is the only way that we can really proceed. And I think that is where this workshop is absolutely valuable. We will definitely build on this. So I don't know if my other colleagues, CIPM colleagues or anyone else wants to add, like Tom, Martin.
Thomas, please.
Yeah. When I think of use cases, there could be two kinds. One is where, the metrology know-how and knowledge is being digitalized and being offered as a service to the community, right? While another spectrum of so-called application or services could be one that is driven by the outside world, the industry. For example, those that are with the industry 4.0, additive manufacturing and so on. And then they are facing, or they have applications where they are facing the issues of, as mentioned earlier, data quality, data confidence, and so on. And I think that's where, again, metrology can kind of help. But at the same time, I think there's also the thing that we want to digitalize our services in the metrology community. And this where we will have to tap on the know-how and the established or existing digital technologies and so on that's out there to bring us to a different level to be able to function in the digital world, where, as we already heard, we are in the digital revolution, we are in Industry 4.0, era, and those are happening very rapidly, and we have to be in that, we have to digitize ourselves in that context to be relevant to them.
Thank you very much. I wonder if I could come to another question now, which has come from Stuart Chalk. Can we estimate data quality by analyzing the composition of analysis-ready data? I come to that question because Thomas had just raised for us there the question of representing uncertainty. Who'd like to answer that? I know Blair Hall and Alistair Forbes done a lot of work and publications in this sort of area. Who'd like to start, Blair or Alistair?
Off you go, Alistair.
Alistair, is
you? Yeah, okay, well, yeah, so this is a very interesting topic, and it's also an interesting topic in terms of what we mean by analysis-ready data. I was very keen on using the phrase analysis-ready data, but when I did a Google search on it, it was almost always referred back to Earth observation data. We were taking satellite data, doing a whole pile of filtering on the raw data, eventually to get an image, which would then be ready for analysis. And I felt as though that wasn't a good representation of what we're trying to do here. But if we think of analysis-ready data as data for which all the provenance and the traceability has been documented, and that that provenance and that documentation is transparent, so that the user can see to what extent any issues that user may be worried about has been addressed in the data. And then I think that's that's the sort of thing we're trying to do. And I guess that's the sort of thing that FAIR is trying to address, is to provide enough information so that a user of a data set has that information to say if this data set is fit for purpose or not. Just the same way in the specification of a car or a project or a camera will allow you to say whether or not you want to buy this camera or not. So I think uncertainty is one element of that data quality. And it's the one that we quite often focus on in metrology because that's how we earn our money. But there's all these other issues that need to be addressed, in particular if that data is a result of a whole pile of analysis. And as we said earlier, the computational component needs to be qualified just the same way as the traceability element needs to be qualified. So that's my starter on that question.
Thank you, Alistair. Thank you for bringing us back to FAIR, which is, of course, a big theme for the conference. Blair, do you want to continue on the topic?
Sure. I think one of the things about our view of traceability and the quality infrastructure is the way it works is that everything should be auditable. We verify and validate all the steps in our measurement procedures. I guess this is something that Alistair was alluding to as well. So it's not just the data and its provenance, but it's the fact that it's been verified and validated as well that makes something ready for use and trustworthy. We claim that traceable measurements are really trustworthy measurements that you can base critical decisions on. And our claim to that is based on the fact that they will have been verified in some way, and that the processes generating traceable measurements are verifiable. So that's an aspect that we need to explore a little bit more, because I think it adds a whole layer of complexity to what needs to be captured and how it can be interpreted by other users of the data.
Okay, thank you very much. Now, we just have 5 minutes left, so I'm just going to bring up one more question, which is from Enrique Gaeta. What should be the degree of involvement of the accreditation bodies to respond to the needs of the digital infrastructure, considering the advances of the metrology institutes? Now, I know nobody here is from an accreditation body, but you bring the perspective of the NMIs. So who would like to say something about that? Vinand, please.
Yeah, Martin, what I quickly want to say, and perhaps from an AfriMed's perspective, we work so closely with the accreditation bodies in Africa because we rely on third-party accreditation for the NMI quality systems. So we are already discussing at the Pan-African level, discussing with our Pan-African accreditation body, AFRAC, so between AfriMeds and AFRAC, how really to work together on this whole issue. So I think at the continental level, we are already doing it. And I can just see that at the CIPM, BIPM, ILAC level, we are really going to discuss this in the next month. I think there's already a meeting planned for that in March, if I'm not mistaken. Thank you.
Thank you. Anything else on this one? Sasha, please.
Yes, I just want to say that there are two levels of that, I think. One is the accreditation bodies should themselves use digital technologies, and they will need to rely on developments from the NMIs. The keyword here could be remote audits or any kind of self-accreditation or self-acts. But the other point is the quality assurance or the quality validation when the NMI start doing digital transformation in a broad way. So we need to be able to check the competence, validate the competence of institutes, of NMIs to do that digital transformation in a proper way. And that's why we need these accreditation bodies.
Is there another contribution from another region here? Hugo or Thomas?
Okay, Martin, I think the International Quality Organization is a very integral part of our partner. In the past, even when we do not have the digital transformation, we have been working together to ensure, a robust, good quality infrastructure, and we need to work hand in hand with each one to enable the value and the confidence in the end product of manufacturing, in trade, and so on. So I think that will continue even in the digital world. And it's right that if there are already some initiative in the other QI bodies in digitizing their processes. So I think, of course, there's a need to coordinate to make sure that the processes that is translated from our physical world to the digital world is robust again and is correct and accurate for the purpose, fit for purpose of the trade and other applications.
Okay, thanks very much. Now we're at 19 minutes past 2, and we have to close at 20 past 2 in order to close this meeting room and give everybody a chance to sign into the meeting room for the final session. But as we close, I'd just like to say, I can see there's a lot of interesting questions have come up. On the top of my screen is one there about uncertainty, about a very technical topic that I think a lot of people want to discuss. That prompts me to say that at BIPM, we're going to be organizing some webinars based on the speakers who've been involved in this conference. Many of the speakers have got a lot more to say that's of interest to the community. They've not been able to bring all of that in 20 minutes. So we will be promoting those webinars and organizing those in the way we do from the BIPM. If you have particular requests for webinars, then please send those to me. So as we close now, I want to say a huge thank you to everybody who's been involved in organizing the meeting, particularly Celine Felag and Joanne Flamont in the meeting office at BIPM and the Lenny staff. And I'll say that we will be sending out a questionnaire next week for you to give your feedback about the meeting. So at this point, I'm going to say a temporary thank you, a temporary goodbye, a big thank you to our speakers here. You're going to see some of them again if you sign out from this meeting room and join in the meeting room. If you go back to the dashboard page, the landing page for the conference, and sign in again for that topic 2 for today. So at that point, with all the panelists, I'll say thank you very much and hope to see you very soon indeed.
Goodbye. Thank you very much.
Thank you.
Goodbye and thank you.